Hi, I'm John McMillan, and welcome to today's webinar on perfecting your PCB with DFM analysis. DFM issues are all too common, from PCB layout to manufacture and testing. In fact, a single fabrication holdup can cost you untold amounts in lost productivity. Integrated DFM analysis allows you to identify and correct potential fabrication and assembly issues in the design database before they hit the production floor. Without DFM analysis, you're essentially leaving changes in the fabricator's hands, where the focus is often on increasing fabrication yield, not on the electrical performance of the final product. To show you how integrated DFM analysis in your PCB design flow helps you achieve first-pass design success and get your end products at the highest quality and reliability, getting you a competitive advantage, I'll turn this webinar over to Shivani Joshi, one of our technical marketing engineers, to demonstrate how you can avoid fabrication issues with integrated DFM analysis in PADSPro. Shivani?
Thank you for the introduction, John, and welcome everyone to the PADSPro Design for Manufacturing webinar. In the past, design for manufacturing, known more commonly as DFM, was typically a process performed by manufacturers, fabricators, or companies which owned high-end DFM analysis software. The most a PCB designer would contribute before a design was sent to manufacturing was a DRC or basic integrity checks. Now, in order to save time and keep designers and fabricators on the same page, is having a simple way to relay manufacturing information that is complete and details key checks that can apply to all members of the PCB creation process. In this webinar, I'll cover some of the typical issues engineers run into with DFM, helpful checks designers can run, and output files generated with PADSPro. There are many DFM issues to take into consideration as we design boards. A few common issues engineers tend to see are insufficient proximity, annular rings, and slivers. Proximity between traces and other electrical components can become a clear hazard. If pins miss a clearance from a plane layer, there's a chance the pin and plane can tie together all the voltage from the plane. Annular rings are the remaining ring of copper left after drilling a pad, and when designed too small can create some major issues. Pads can delaminate from the board, or disconnections can create shorts on the plane. Slivers can be a potential and unexpected hazard when creating boards as well. Small copper slivers can detach themselves during assembly and accidentally reconnect themselves anywhere on the PCB. This is an area of concern because this can short a net and ruin the entire product. Studies show that it can cost a PCB manufacturer as much as 20% of the cost of the PCB for CAM engineering to prepare it for manufacturing. If a design is submitted without DFM defects, teams see a decrease in overall cost compared to manufacturing boards with DFM defects. Luckily, designers can take action before sending their designs to manufacturing by running convenient checks on their layouts in PADSPro using DFF analysis.
Design for Fabrication Analysis, or DFF, enables you to find potential fabrication errors before you generate manufacturing output data files. You can check for same net layout problems such as acute angles, potential slivers, and acid traps. At different design phases, different DFF analysis are recommended. In the post-placement phase, proximity of components is key to focus on. Analysis during post-routing should also include all planes, solder mask, and solder paste. Once the design is finalized, a full batch DFF analysis is recommended. After selecting Analysis Batch DFF, you'll see a Batch DFF window where you can customize the analysis to focus on your specific issues. You can analyze an area of the board or the entire design. The next step is to set up the analysis. Select among all signals, planes, silk screens, etc. on as many layers as you'd like. Here, I'm only going to look at the whole plane on layer 6. Selecting this criteria automatically selects the individual analysis to the right. After processing the design, I can see that there were no element-to-element hazards, but there were 11 sliver hazards. All files created when performing DFM analysis can be found in the file viewer in PADSPro layout. Going through the report, it's clear to see what was analyzed and where hazards were flagged. Now, to address the issues, the Hazard Explorer will save all hazards generated when I ran the batch DFF analysis in the DFF tab. Each potential issue is marked within a filtered set. All the issues for this design are in the signal ratio based sliver category, and all nets with issues are clearly shown with a quick link to the location of the problem. Adjustments can easily be made by the designer here instead of waiting for potential problems during or after manufacturing. All rules can be managed in the DFF Rules and Clearances window. Selecting among the DFF categories, proximity to the signal, drill, and solder mask, and rules for signals, planes, drills, solder mask, and silkscreen. You can control each of the parameters and adjust the value of severity. A serious issue that tends to arise between board designers and manufacturers is miscommunication. Sometimes, assembly engineers will not communicate all design changes back to the design engineering team, causing issues with the saved PCB design database. In order to produce information in a way that is clear to review and understand by both parties, PADSPro allows designers to create unique drawing sheets and define panel data with Drawing Editor and FabLink respectively. Drawing Editor allows you to create drawings that document the PCB design for manufacturing and assembly purposes. Drawing Editor is integrated with layout and manufacturing products so that any changes made to the PCB design or the panel design can automatically be reflected in these drawings. You can create multiple sheet drawing files such as assembly or fabrication drawings that incorporate the PCB design. With ease, add a sheet with important information to keep for your own records and to send to applicable parties. Here, we'll create a sheet with information regarding layer 6 of this design. In this sheet, we can add a layout image of specifically layer 6's vias, routes, components, rule areas, and more. Arrays can also be added with a simple check. We can also add a layer stackup with data on layer name, thickness, and details of all the contents on these layers. Drill tables, panel placement, and components can also be added in similar ways. External tables can also be imported with unique data sets from outside of the software. For example, revisions and general comments collected throughout the design process that might be important for future reference. PADSPro also allows for you to define and manage panels to conform to manufacturing processes by using FabLink to create panel designs for your boards. You can lay out your panel in different ways depending on your PCB design and the method of manufacturing, either single board or flip-flop panels. Single board panels contain a single PCB design where each instance of the design is placed on the panel as either an array or a tiled board. Flip-flop panels contain a single PCB design where each instance is placed on the panel flipped, per its name. FabLink opens with a panel outline and border, both which can be edited to manufacturer specifications, where you can place the single board or arrays. With Place Board, you can choose where to place the board. Here you can also select to flip your board. Uploading design data allows users to see how their design fits in the allotted space. To create an array of boards, go back to Place Board, then select and customize the array. Drawings and panels are used to organize data, but in order to manufacture a design, files of a different nature are required, ones with detailed information to guide fab engineers and machines to build the desired product. There are several easy output file generators within the PADSPro toolset: NC drill charts, Gerber, and ODB++ files. Numerical controlled drills, or NC drill, output files are used to provide manufacturing tools with drilling, punching, and routing instructions for PCBs and panels. They can also be used to create drill charts and drill data that documents the drill holes, symbols, and locations in the design. The drill generation is customizable. Adjustments can be made with the drill and chart options. Going back to layout, the recently created drill chart can be displayed by checking the drill drawing options in Display Controls. This allows all users to review the drill information and locations as they continue with their work. A common manufacturing output option used in industry are Gerber files. PCB manufacturing machines use Gerber files to lay out electrical connections like traces, vias, and pads for manufacturing printed circuit boards. Gerber files can also contain information for drilling and milling the board. To create a Gerber output file, simply go to Output, Gerber. Here you can select which files to include and customize the content of each of these files. Here, I'll select the drilled drawing, etch layer from the bottom, and the top solder mask. To edit the contents of each file, look into the Contents tab. Here, each layer and item can be selected for each output file. The design items and cell content can be selected or unselected based on what you and your manufacturer prefer. All Gerber files can be easily found in the project file under PCB Output Gerber. Editing, adding, or sharing files can be done easily now that they're saved conveniently. Another common manufacturing output file format is ODB++. The ODB++ format represents the complete layout design for interfacing with Valor assembly and manufacturing tools and other third-party applications that accept ODB++. ODB++ outputs board data into a hierarchy, making it easy to manipulate. In the ODB++ output generation window, you can once again select what information is created. Easily select different options to export, such as silkscreen information, outlines, nets, and packaging data. Then, select layer information to include in the output file and map user layer data to one or multiple layers. By selecting Launch ODB++ inside, the software performs several steps to compare the generated ODB++ output with equivalent reference files to identify variances. Easily select layers, review the CAM data files associated with them, and clearly see the status of each selected layer matching the data in Gerber or CAM reference files. From this demo, we've seen how simple DFM checks and documentation can be from a designer's view. In order to prohibit costly respins, DFM checks and pain points can be addressed before sending designs to manufacturing. We also saw how easy it is to create documents that allow all teams in the PCB generation process to see every aspect of the board and panels. Historically, DFM checks were primarily done in the fabrication and manufacturing stages, but it's clear that the later a change in the design occurs, the more the total cost increases and there are generally major design respin time losses. So why not check your designs earlier with PADS Professional?